Hello, folks. It's been a great couple of days in Paris. The weather didn't live up to my expectations, I'm sorry to say. And what's even worse, it didn't live up to my wife's expectations, but nevertheless, I've seen a good deal of your beautiful city, and it was quite fun. So today I'm going to talk about continuous delivery, and specifically about continuous delivery in Java. My name is Jevgeni. I'm the founder and the CEO of ZeroTurnaround, which is a very cool company, I don't mind saying. You can follow me on Twitter as Kabanov. And hopefully, today my goal is to talk to you a lot about our story. ZeroTurnaround both has internally built continuous delivery pipelines or workflows, and also has built a product for facilitating continuous delivery. And today we're going to, both share our experience in building those pipelines and a little bit show you off the product. So you may know the company. We have a product called JavaRebel. It's our well-known product, which has been started lots of years ago, which is used by a lot of people. How many of you are using JavaRebel? All right. So those of you who don't use JavaRebel, you really should try it because it's going to save you a ton of time when doing development. But this is not what I'm going to talk about today. Today I'm going to talk about FedEx. So FedEx, FedEx delivery is like you package, you drop it off, you transfer, it goes from point A to point B, and then it's delivered to your door. And then, somewhere in that point also FedEx makes a lot of money. The cool part about FedEx is that, every step of this process is tracked. And you actually, you can go to the website, insert the tracking code, and you can see okay, my package is right there, stuck in some middle of nowhere, waiting for a bus to pick it up or something like that. And also that most failures, if somebody accidentally delivers to the wrong place, failures are recoverable. Sooner or later, they'll do the inventory, find your package, and deliver it to you, right? It may be delayed, but it's unlikely to be actually lost. It happens, but it's rare. So Java EE, by comparison, you package, so that's similar. You test, okay, that's something weird. You approve, so before anything actually goes to the users, it got to be approved. Then you deploy, and then you profit. So we also have we have a similar number of steps. I chose some steps and didn't choose the other steps, but we have similar number of steps. But for some reason, it seems pretty easy. It's 4 bullet points, but for some reason, everybody complains about it. Always there are issues, always there are troubles, always it's hard. You need the whole staff of operations to support it. So why is that? Well, one of the reasons why people complain about it is because most of the actual deployments happen at 3 a.m. on a weekend. And those poor people who get to actually do the deployment, they're pretty unhappy. But that is not the main reason. The main reason is actually because this is what the FedEx fail looks like. Right? So what you may notice here is that it's pretty recoverable, right? So again, your packages will get delayed, but nothing horrible will happen. But this is what a software fail looks like. So what you get is, all your users for whom you build the software can't use your software, right? So that's a very big problem because those people probably can't do their jobs, which means that, you lose a lot of money. It's not just like an incompatibility as in with FedEx, it's actually a catastrophe, or it can be, especially with something that is deployed large scale. When Gmail goes down, then basically, me personally, ZeroTurnaround uses Gmail is Google Apps for a domain or whatever they're called, and when Gmail goes down, we can't do our work. Or a large part of us are pretty much very sad, or even Google Docs is even worse because all our specs are in Google Docs and so on. And it's an issue, right? So the problem with software is that software failures have large impact and they're very likely, versus FedEx failures, which have very low probability and low impact. Software failures typically have high probability and high impact. And this is an entirely different process to live in. So, but the thing is that, okay, so that's fair enough, but how do we fix that? And the first idea that I would have if I would just, as a thought experiment, if I would want to fix it, then, we are software professionals, we're engineers. We have a customer who has a problem, right? So we do analysis and we try to understand what are the steps, what is the problem, why is it, what is hard, and then we write software to basically encapsulate that, right? That's how we all solve problems. Is it fair? Okay. So let's try to analyze, like from a kind of like a detached standpoint. Well, we're coming in, we're not anymore developer. We don't anymore. We step out of the shoes where we actually are doing that, and we step into the shoes of somebody who tries to analyze it as for a customer, right? So and then we just start to ask questions, right? So that's how you do analysis. You ask a lot of questions and you try to understand what's going on. So first of all, how do you package your application? So there's several ways to package, but also there's some interesting questions like where did the dependencies come from? Did they change between versions? What's the file name? And where did they actually go? Okay, where did it actually go? That's very interesting, but where did it come from? So did the package just materialize out of thin air? Did the project lead build it? Did the project lead tag it and then somebody else build it? Did the lead tester pick one? Did the business guys pick one? Right, so there's so it's kind of a lot of options here. Where does it go? By email. So we actually literally have a customer who has they build shipping software which runs on JBoss, and when they build the EAR, they actually send 100 meg EAR by email, and those guys on the receiving end, get it, save it, deploy it on the server running on the ship. So it can go by email. It can go. Maybe there's a 20-step printed out document which says like, okay, now do this, now do that, now do this, now do that. Maybe there's like a bunch of shell scripts and AND scripts which sometimes erratically fail and you don't know what's going on. Maybe there's a CI server. Maybe that's what automates everything. Maybe that's what says where things go. How does it get deployed? Will users have downtime? Is it during night or is it during day? Do people have to do overtime for that? Right? How many people are doing the deployments? Do you have a lot of errors? Do you upload like through web UI, or is it like some SCP, or is it like some AND scripts or shell scripts? So do you use a tool? So, and what exactly is in production now? So that's a lot of questions, right? So who knows what is in production? Does manager know? Does developer know? Is it in the email? Is it in the wiki? Is it in the CI server? Is it in the server logs? So the reason, the reason why production, like the whole this process, like why this building software and deploying software is so hard, is because it's hugely complex. There's very many variables. There's a lot of variables. There's a lot of variation. It's much more complex than what we have to deal with, even in FedEx, right? Which still is kind of like a relatively predictable system with little failure, little variation, and little impact of failure, right? So probably in the last few years, I had like hundreds and hundreds of conversations of how do you deploy your software? How does your software get basically from a developer check-in to the actual running software? And the uniting theme of all those conversations is that they're all different. There's like not two ones alike. I heard everything started from like, we build an RPM with a Tomcat and we just throw it at the server, to like, we copy files manually, to like, there's like a paper going around the house that everybody has to improve, and on the other end that somebody presses a button and everything happens automatically, and we deploy to 5,000 servers, right? So I've seen like basically it's all very, very different. And the reason why it's very different is very complex, and that's why continuous delivery, it's not like a simple recipe, but it's more like an approach to how to solve complex problems. So continuous delivery, it's more comparable to Agile as a methodology rather than something like that you buy a piece of software and that's it, it's solved, right? So it's an approach. It has to go, and it goes side by side with like DevOps, which means that guys in development, in operations, and in business actually talk to each other and trust each other. It's kind of crucial. So you have this kind of process part, and you have this, and when you have the process part right, then you can also do the technology part, right? Or they can go side by side. You can just improve them one by one. So that's, continuous delivery is the solution, but what is continuous delivery? So that's an interesting question. Well, obviously it's a pipeline. So you go, from point A, and then you bump to point B, and that's that's sort of pipeline. There was actually a very nice talk by I think Dave Farley, who literally wrote the continuous delivery book, and he actually said that one of the interesting things he said is, although they called it a pipeline, then actually it's not a pipeline because there is no this linear progression. It's all like there's all kind of like logic gates and and things like that. So it's not actually a pipeline, it's more like a workflow. It's more like, you start from point A, and then you get to one of the points in the end, maybe, and maybe you stop in between, and maybe you alert somebody. There's a lot of these actions that can go in between. It's not like so straight as you start at point A and go to point B. But everybody calls it a pipeline, so I'll also call it a pipeline. But it's not quite, the pipeline that you see on the photo. So, not quite a pipeline. So what is it? It's an automated trackable workflow, right? So automated means that human intervention is necessary only where it's unavoidable, like for example, like manual testing. Trackable means that every single step leaves a trace, and workflow means that all the logics is recorded. And it generally consists of three kind of services which you will need, and a lot of glue connecting them all. So we have the orchestration service, which actually encodes the workflow. You have a delivery manager, which basically takes care of the actual deployment. When all the workflow, basically the last mile of the workflow, when everything is vetted for, and now it actually has to go out to the users. And you have an artifact repository, which kind of also a little bit of glue because you need to actually be sure, it's good for recording information about artifacts and basically kind of helping that process along. So it's not quite a pipeline, but it can be often represented as one. So, and we'll actually use the pipeline plugin at some point. So it's also kind of a pipeline, kind of not a pipeline. Depends how you look at it. So orchestration service is typically, for orchestration service, we personally choose Jenkins. It is the most popular continuous integration server, but it's kind of a bit more than continuous integration server. So that said, TeamCity and Bamboo are the other two popular commercial servers, and they're entirely also would work for this. As would some others like ThoughtWorks, Go, and a few others. So, but we choose Jenkins just because it's the most popular one, and so everybody probably knows it. Who knows Jenkins? And who actually uses it? Okay, so very good. So it's a continuous integration server, and continuous integration, basically the idea was, it was like the continuous integration server was invented like, I don't know, almost a decade ago, I guess, like some 7-8 years or something like that. And the idea at that point, everybody did also builds manually. So the idea was to at least automate, the build part. And that's why it was continuous integration. But really, it's more of an orchestration platform, right? So you kind of encode your workflows, you encode what depends on what. You can start at a certain time, you can trigger it, you can send alerts. So it's more like an orchestration platform or an automation platform. You can call it that as well. So, and you also get all kind of enterprise features, so logging, notifications, clustering, UI, authentication, authorization. So what we like to call it is that it's CRON for enterprise on crack. So that's just one way to look at it. It's like just a really, really pimped up CRON. Well, it's a lot more, but it starts at some jobs executing some time, and then you add everything else. So on the other hand, for the delivery platform today, I'm going to choose LiveRebel, which is our product. So it's commercial, but it's basically is a deployment manager created by engineers for engineers on LSD. So why is it different? Well, for starters, there's not a lot out there which is focused on delivery, but it's very cool stuff. It's the reasons why we choose LiveRebel, or like the reasons why we why our customers use LiveRebel is because it doesn't, we can install it in any existing infrastructure. It doesn't need any configuration. It has exact knowledge, like it has a dashboard tool. It will show everything about your system, what versions are deployed where, what servers are running, what servers are not running, and what's going on in your system. It supports this, the biggest, kind of selling point is that when you do an update, whether it's whichever way it is, it's always invisible for the users. So you can do it during the daytime while the users are bounding your application, and and LiveRebel takes care of either of automatically updating your application, and for users is completely invisible. And also it has failure recovery, which means that whatever update went wrong, you can always go back, and you can always, like a panic button, you can press and go back to the previous version. So it has some nice stuff in it. So you can deploy and deploy, you can update. There's never any downtime, there's never any lost session, and it uses either like our own proprietary hot patching, or it just uses classical server restarts, so kind of like rolling restarts from one server at a time, or like a few servers at a time are restarted, and requests and sessions are routed to those other active servers, right? So, and you can even, if you're very, very adventurous soul, you can even edit things in place, like JBoss way, when you go on the server, you edit them something. And then you actually still create a new version. So why LiveRebel particularly? Well, there's not really a great open source alternative. It supports all containers. It supports no downtime updates. It integrates with OSS projects like Sam Jenkins and some commercial projects as well. So the alternative that are available in open source like Cargo, Capistrano, and then basically you're stuck with the bindings that containers provide, like containers provide Ant or Python or Maven or whatever bindings. So you can do that. You can script it yourself, but LiveRebel manages everything out of the box, and it leaves a trail, and it does this no downtime updates. Okay, so together Jenkins and LiveRebel are pretty perfect. The one thing we're missing here, and which I'm not doing in this talk, is the artifact repository. So the reason I'm doing everything on the local environment, and also because my local environment got so complex that I just didn't have time to configure an artifact repository. But generally, you want to have a third component. So here, I'm using an artifact repository, basically the file system, right? So, but in a larger environment, you probably want to use an artifact repository as well. So let's build a trackable pipeline. That's it. No more slides. All right. So what I have here, maybe I'll make it a little bit bigger. There we go. So what I have here is Jenkins, and Jenkins actually has a thing called the pipeline plugin, and it has a demo pipeline. We're going to get into that. I also have LiveRebel. So LiveRebel, as I said, it manages applications and servers, and what we can see that I actually have 4 Tomcats on my tiny little MacBook Air 11-inch. So I have 2 production servers, 1 staging and 1 testing server. So we're going to build a pipeline that goes testing, staging, and then production. So then I have actually a load balancer. So I have the 2 production servers are behind the load balancer. And I also have, and here I have the Tomcats, or actually two Tomcats, and then this is the load balancer. And do I have anything else interesting? No. So and also behind the scene, 3 Redis servers are also running. So that's pretty much a lot of stuff running, and hopefully I did sacrifice a goat in the morning, so hopefully the demo gods are kind to me, and nothing will fail. So let's go back to Jenkins. So I'm not even going to show you the current demo pipeline, but I'm going to just start building one, right? So I'll start from scratch, building a new demo pipeline. Okay, so first of all, I have an application which is a chat. So I have usually I would give you an address. There's actually, if you really want, you can connect to Yevgeni's MacBook Air. It's an ad hoc network. I don't know if it actually gives a DHCP address, but it might. And then you actually can, if I find out my IP, so my IP is apparently, so I have a self-assigned IP, which is very annoying. So 169, 254, 27, 172. If you really want to, you can connect and kind of simulate the users so that it would be more interesting. So, okay, but the application I have is a chat, and I'm just going to start building it. So it's a Maven. It's built by Maven. And I create a new Jenkins job. And so one good or bad thing about Jenkins that it has 1 million plugins. So it's a good thing because you can do everything. It's a bad thing because you can do everything. And, and it's kind of hard to figure out what you're doing. So it's a Mercurial, so I'm going to build it from a Mercurial repository. So I'll just copy the Mercurial repository from here. And okay, so I don't need to specify the branch. I'm going to use it, so it's going to be clean install. Well, I can also actually fingerprint. It's going to be useful, maybe. So, and at the moment, I don't need, I think, anything else, so I'll save. So, okay, so now we have a job that builds basically a WAR file, right? So it builds a WAR file and it installs it in the local file repository. So now we want actually to do something with it, and we want to create an acceptance test. So I'm only going to simulate the acceptance test. I'm not actually going to create one, actual test, but I'll just create something that is a Jenkins job and that takes place of the acceptance test. And then once you have that, basically you can, you can pretty easily put anything there. So I'll have an acceptance test job. It's also going to be a Maven project. So it's also going to be from Mercurial. And that one called deploy for demo. So let's actually see what that does. So whereas the previous one built the WAR file, okay, so it's Mercurial. I don't want to build it at all, and it should have -u install. So the reason for -u is so that basically it would take the latest snapshot. Because otherwise, if you don't supply the -u to Maven, it doesn't update snapshot. And what we're going to do is the first step in the build is going to build the snapshot, and the acceptance test is going to try to get the snapshot and test it. So again, we can add fingerprinting. Let's see if that works. So okay, so now we have 2 steps, and let's see what the actual deploy for demo does. So let's just look at the POM XML, and it's kind of like a, nothing. I'm thinking, okay, actually maybe Y here is better because I can control the size. So it doesn't do anything almost at all. What it basically does is that it downloads the Maven dependency and then copies it to the in the target to the file name or demo var. So to a predictable file name, latest dependency to a predictable file name. Interestingly enough, this is the actual project we use internal at ZeroTurnaround. Because we have large distributed builds, so we have a lot of servers, which is not uncommon, and then we use that to download the latest, some of the latest file from the repository. And for the basic reason was that we couldn't get the Jenkins file copy plugin to work. So we had a lot of trouble, and then we just decided we're going to write a Maven, small Maven project, which basically does nothing else than copies the file from Maven repository to a predictable file name. Maybe you can, it's probably doable, just it was easier for us to do that. But anyway, so this doesn't do anything, and for acceptance tests, we ignore the actual output. So it's basically just kind of a placeholder. And finally, let's also add a deploy also. So deploy testing 2, it's also going to be a Maven product, and actually we can even copy it from acceptance test 2, because it's not actually going to be so. So it's basically almost the same. It also builds the same dependency, but there is one crucial difference. Once it's actually finished building, it's going to deploy the actual artifact with LiveRebel. So let's go with other demo. I think it's like target. Yeah. So this is what we need: this target/other demo.var. This is what we need the actual POM XML. Because that copies from the file system, from the dependency, installed dependency to the LRDemo.var. And this is we're simulating supposedly a large, complicated system, And by the way, if you noticed, it's a pretty, it's a small simulation as I could get it to be, and it's really getting kind of hairy. There's a lot of moving parts here, right? So, okay, and what we're going to do is we're going to use offline update because this is testing and because rolling restart requires at least 2 servers. But by default, LiveRebel will actually use hot patching. So basically what LiveRebel does, it validates if the 2 versions are compatible for hot patching, which is updating the classes and resources in place. And then if they're compatible, it will go through hot patching. And if they're not compatible, then it will go through either offline restart or rolling restart. The main reason for not being compatible is any kind of state changes. Like if you added a field somewhere or something like that, like if you created more new state which won't be, which we can't really populate, then that's the main reason for something being not compatible. And by the way, one kind of interesting thing is that generally if you look at the whole problem with this kind of last mile with delivering the update to production, there are two problems you have with delivering an update to production: state and users. Right, so under state, I mean everything like database, internal application state, caches, because always the problem is how do I replicate that state, sessions, everything, right? So how do I get that state from one server to another? How do I make sure that the state, preserves or is recreated correctly after the server, after their update? And the other problem is users. If only those pesky users will stop pounding the application, then it's quite easy to do an update. Going back to this, we're going to deploy the application to the Tomcat testing, and that's it. Okay, so these are the 3 jobs which should end up in deploying. Unfortunately, we need one more thing to do. So now one thing I can create a pipeline. So I'm going to create a demo pipeline, and it's going to start with build chat 2, and it's going to show last 5 jobs. So unfortunately, okay. So first of all, fortunately, when I go offline, for some reason, Jenkins doesn't hide the legend anymore. When I'm online, it hides it. When I'm offline, I don't know, does it go to jenkins.com to ask for a script or something? But it just doesn't work. And second, we don't yet have a pipeline. We have only one job here, build chat 2. So what we actually also need to do is we need to go to build chat 2, and we need to connect those jobs. And this is like something that is actually really ugly with Jenkins. I don't know, there may be some improvements coming up, but at the moment it's really ugly because basically what you have to do is you have to say what I'm going to build, like directly. And if later down, if you build something complicated and something changes, then it's really hard to reconnect them instead of having kind of these pluggable jobs, and you have like some parent job which actually orchestrates it. So that's kind of a bit of a bummer, but it's still usable. We have 300 jobs at ZeroTurnaround, so that's it's pretty complicated for us. It might be much so deploy testing. All right, so now if we go to the demo pipeline, we actually have now 3 jobs in the pipeline, and if we start it, then it's gonna unfortunately really wish it would hide the pipeline. I just don't understand why it doesn't. Okay, so now we have, you see, so every time we start a build, we kind of start a new pipeline, right? So a new version goes through the pipeline. So now it hasn't found the revision, probably because I didn't do something correctly, but it basically is going through the pipeline. All right, so we built the application, we installed it to Maven, the acceptance test downloaded it and did nothing with it, but the idea is that acceptance test is the one that can fail, and now we actually are trying to deploy it. So deployment, as you remember, goes through LiveRebel to one of the Tomcat servers. Okay, so let's look how it, okay, so it's deployed. So now let's go and look what the applications look. So we have now one application, which is our demo. The version is, latest version at least is 1.0 snapshot, and it deployed to one server. So here we see that again, Tomcat testing, the version, everything. And this is actually, if you don't use LiveRebel and continuous delivery, then this is actually how you use it. Like you can select any version you want and any strategy. But we're gonna actually see that later when we simulate a failure. So that is pretty complicated, but it's a very simple pipeline. So it's relatively simplistic even for this, but it gets very complicated very quickly. So this is what what my actual pipeline looks like. So I'm adding also performance tests after the deploy testing, then deploy staging, and then deploy production. The interesting part also in Jenkins is that, so if I click on deploy production and configure it, so it's basically, it's almost the same as the other deploys. It also goes to LiveRebel. It deploys to the 2 servers. It uses rolling restart as a fallback strategy, and it also deploys to 2 servers instead of 1. Right, so that's why it can use the rolling restart. It can take 1 at a time down if necessary. But another thing that it has, and actually I'm wrong that it's not even this one. Another thing that it has is that performance, deploy staging actually has that, so be pipeline plugin manually execute downstream project. So this is, and it says what project does it execute. So why is this important? Because this is what makes the difference between continuous deployment and continuous delivery. So continuous deployment says that everything that passes the workflow automatically goes to production. Continuous delivery says yes, but the actual guy who presses the button is the business guy who understands the needs of the business and who basically decides which versions goes to production and when. So, and the difference is that this adds a button, right? So it adds a trigger button right there, and this button will actually trigger the production deployment. So let's again start a new job. And meanwhile, while the job is running, we can also go to testing. So this is the testing, I think. And we can actually see that, not only in LiveRebel does the application run, but actually it's also existing here. And it doesn't have smileys, by the way. So that's a very sad chat. It doesn't have a user list. It has, I can actually go my users. But it doesn't have any smileys, and it doesn't have a user list. So that's kind of sad. Another interesting feature here is that this weird kind of hash code you see, this is actually the part of a session ID, so that we could track when the sessions change and like when the state is lost. So that's because we wanted it has a little bit of state which is hard to replicate. Okay, so now let's go back to the pipeline. So we having this deploy testing running. And basically, it's going to continue all the way through to production. And what we actually want to do, so let's deploy to production. And then what we'll want to do is also run it once more with an updated version of the application and see that it actually is also working. So let's try doing that. So we have deploy staging. I didn't want to deploy the previous one because I didn't know which version does it use. I was experimenting a lot before the demo to make sure everything works. Okay, so now I'm pressing the button, so I'm triggering the production deploy. So did it actually trigger? What's going on? Kind of confused here. Too many pipelines. Interesting. So is there actually any jobs running? Great, so that's obviously another thing that doesn't work while the Jenkins is offline. I don't understand. Okay, so I'm just going to run that particular job, I think, manually. I think I should be able to run it from here, maybe. So let's run it, and let's hope that it actually does something useful. Yeah, it shouldn't be parameterized, so it just grabs the latest version, and we don't have that. So if you have an artifact repository, then you actually also, what you do is you tag the artifacts in the repository to know which is the latest, like vetted one, so which will actually go to production through continuous delivery. Okay, so now we actually have it also here. So this, as you remember, this is the load balanced one. So this is the production one. This is, and now we have the version here. And let's try updating that. So what I'm going to do is I'm actually going to do a kind of an evil thing, and I'm going to back out the change, which is the head change. So hopefully that will work. So let's also should have here find. All right. So now the difference is that now we have emoticons. So let's see if this actually updates. Okay, so let's start another pipeline. So this is now a new version. Something is kind of not working, and I didn't change a single thing, by the way, but you can see that the previous one which I started, it didn't actually have a revision, whereas this one has a revision. And I didn't change anything, like all of them are the same, and like sometimes Jenkins can be a little annoying. I'm definitely thinking of also investigating Bamboo and TeamCity for orchestration because, as I said, the great part about Jenkins is just, if you want a plugin for something, it's there, it exists, you can find it, you can download it, install in seconds. The bad part about Jenkins that whether that plugin will work for you or not is, it's an open source project. There's not a lot of testing, there's not a lot of documentation, but there's a lot of functionality. So that's a typical open source project, which hopefully, now it's actually backed by corporations and so on. So CloudBees probably is improving its quality, but I'm still running into some issues. Right? So in test, we should already update that. So actually, let's see the test. Yeah, so we now have a user list. And as you can see, by the way, I still have the same users, and I also have smileys. But let's also see the production. I'm going to try to trigger it again. Let's see if that works this time. So I don't understand what's going on. But OK, I'll trigger it then differently. So let's trigger it from here. Deploy production. Let's trigger it here. I'm just going to keep on chatting here. There you go. So this is, this is where we all want to be, all right? So like you have to understand that. So there's kind of this continuous deployment guys who say like, everything has to go to production, right? And there's a reason for that. And it's the whole this thing about failing fast, right? So if you actually build this automated pipeline all the way to production, that's actually pretty cool. So we have a customer who did that with Jenkins and LiveRebel, and they are deploying 2,000 times a month. Right, so this is just something to understand the context. Right, it's on a completely different level than what most of us are used to, and on the other hand, we have a lot of customers who still do it like kind of the last step manually, and they just want to have the convenience of being sure that their this particular artifact is vetted for. And the convenience of having a nice UI where they can press a button and deploy it, and that's also fine, right? So some of them will, most of them will actually just the last step will copy the version to LiveRebel. So LiveRebel, like it has just a folder you can copy to, or it has API or like the Jenkins plugin, and they'll just copy it to LiveRebel and then deploy from LiveRebel. That's also fine with us, and of course, some of not our customers who we talk to, they have Amazon images, they have RPMs, they have all kind of stuff. So what is the important part, right? So the important part that I want you to take from this talk is that with some effort and some good tooling, it is possible to automate this whole process, right? And if you automate this whole process, it's going to be amazing. And one of the reasons, like, let's say, for example, that this version is actually throws an exception, right? So it somehow impacts the users. We have the whole this availability. Then one of the good things about LiveRebel or generally automating your workflow is that I can go ahead. So I can just look at this. So now we have the same version deployed on 4 servers. And if I want to, I can select 2 of them. So I actually might want to take productions here and take the previous version. So why not this one? So take the previous version, and here's like what I was saying to you, like we can do hot patching and we can do rolling restarts. So hot patching is actually the one that updates instantly. We can use this for this one, and this actually says that it's compatible for hot patching. So if you look, we actually are doing kind of this we're comparing the two versions in depth, like actually on the class level, on the method level, and on the resource level to make sure that it's actually completely and fully compatible. And if I update that, then we'll get the old version back in production. So now I don't have smileys anymore. I'm a sad smileyless. And as I said, also hot patching doesn't work for everything. So if hot patching doesn't work, what happens is that LiveRebel will actually go and automatically restart the servers, preserving the session, preserving the requests, or at least expiring the sessions. So again, if we go, this is the production. So let's go back to the latest version. And let's go with rolling. Don't they have two servers? Okay. Let's go with rolling restarts this time. And let's have like a 1 minute expiry time. So this actually, at the moment rolling restarts, it will expire the session. So it will wait until the sessions are drained on all servers. But if I'll start this, it's actually like all the same things that I can continue using the application. Right, and LiveRebel is just, meanwhile, draining the sessions and so on. And the coolest part, so I'm sorry about the LiveRebel plug, it's my baby, I love it. The coolest part about LiveRebel is that it actually requires almost no installation. So you just attach an agent to a server, which is like really easy to do. And as soon as you have like if you look how I start my Tomcats here. So let's actually look at that. I have this special Catalino script, and all it basically does is uses like LiveRebel's kind of run sh to wrap the starting script, and it's supported for all servers, all containers. There are slightly differences in installation, but it's all the same. And after you do that, then basically, even if the server goes down, then LiveRebel kind of daemon will survive, and that daemon is actually the one that it acts as a mini load balancer during the rolling restarts, and it actually routes the requests, routes the sessions. So it's like really little installation. It plugs in any infrastructure you might have, and it will just automate your whole deployment and update process. So one of the servers is already down, but here, like, everything should be fine. So that happens. And you know what? It's probably because I renamed the servers and didn't rename the load balancer. Demo gods are angry. Okay. So, yeah. Because originally I named them all like Tomcat 1, Tomcat 2, Tomcat 3, Tomcat 4, and then I decided, no, this is a bad name, so I'll rename them to Tomcat Testing, Tomcat Staging, and Tomcat Prod 1, Prod 2. And I think the servers themselves are probably alive, so I'm going to actually try to just bypass the load balancer because, so let's go staging, but I think it's just like, yeah, so the servers themselves, are actually live, so it's just a load balancer that is not misconfigured. It's unfortunate because like right now, again, one of the servers I think is not, they're not, but anyway. Okay, so the demo gods was still a tiny little bit angry, and that teaches me not to change anything. But to finish up, we have 7 minutes left. Of this talk is now we kind of, like if you build a trackable automated pipeline, then you have answers to all of those questions, right? You know who packaged, so it's all, it's the Maven driven by the workflow manager. Where did it come from the artifact repository, where did it go, because you have the whole workflow and you have the, for every version you have the recorded history. How does it get deployed through the delivery manager, through LiveRebel or something similar, and you always know what exactly is in production if you have, again, something like LiveRebel, right? So we have all the answers to these questions, and they're simple, but we had to build a lot of tooling to get there. And that's it from me. Thank you very much. I hope you learned a little bit of something. And I see there's a question. So the question was about database migration. So you can, there's, again, it's, as I said, this whole thing is complex. So if you want to do database migration, you have some interesting tools for that, which actually fit in this process, like Liquibase. You have, if you are doing it manually, you can basically put it into your workflow. And if, for example, if that a database is backwards compatible, which it often is, then you can, can have a manual step in your workflow that this is when I do the database update, and then you just basically, okay, I finished, you press the same trigger, I finished with the database update, and then you just continue with the same, delivery of application through LiveRebel or something like that. So that's again, LiveRebel itself also has some facilities for calling, like you can either, first of all, it has a scripting facility, and second of all, it actually has a facility to kind of pause the update in the middle and do the database update. And this is used when the database update is actually incompatible. And on the larger question, there's configuration update, there's environment update, and I'm not saying that those things are trivial. So kind of what we decided is because it's such a large and such a complex problem, then what you want to do is, like, people would typically kind of think, okay, I can't solve all problems, that's why it's not even worth starting this. But really, if you can manage to, put the 95% of updates through the pipeline, and then 5% you have to do manually once a month, then it's a huge win, because now 95% of your updates are predictable and only 5% of your updates are not predictable, right? So the more you can move this margin, the better you are. But you don't have to solve 100% of this problem. You can solve if you can solve the absolute majority of it, then it's a huge win already. And there's always going to be, there's always going to be some manual work at the edges, but that's what you want to do. You want to push it to the edges. You want to push it to things which are not common, which are not, and then of course you want to push it further and further and further. So that's how it works. Yes, sir.
What do you recommend for golden source for environment specific configuration variables?
Sorry, for what? For
a golden source to manage all the different variables that differ between environment, staging, testing, integration.
So the question, I think, was about how to manage the different configurations in different environments. Well, there's several approaches today. One kind of big approach is let's virtualize the whole environment and let's just copy the whole environment. It has some advantages, it has some disadvantages. A better approach is to use something like, I think personally the better approach is to have infrastructure as configuration and use something like Chef or Puppet. And basically, and again, it should be part of the pipeline, right? So everything should be delivered together, not separately, and Chef and Puppet can take care of configuration, and and other Liquibase can take care of database, LiveRebel can take care of the actual code update. So it's a large, complex problem.
Which one do you use?
We use Chef. Like at ZeroTurnaround, we use Chef, and we have a large cloud deployment. Like we have 25 servers, which are basically our testing farm. And because we have to, we have like 35 or 40 container versions that we have to deploy. And then we have, thousands and thousands of applications that we have to deploy in them. Then we use Chef to manage this all. And it's pretty cool. Yes. Any other questions? Come on, I won't bite. I assume that everything was incredibly obvious and my talk was awesome. And that's why there's no questions. Okay, thank you guys. I'll also take offline. I'll be here for a bit. Thank you all.